Graphing second-order inequalities. As we have explained in the previous tutorials, a second-order equation is an extension of the concept of quadratic equations including a new variable y. This means the quadratic equation, we have the following as shown on screen. Is a special case of the second-order equation with two variables, we have the following as shown on screen. Where y equals 0. The line that represents the graph of second-order equations with two variables is not straight, this line is called a parabola. For example, the graph of the second-order equation with two variables y equals x squared plus 3x minus 4 is shown in the figure. We have the following as shown on screen. Following the same reasoning used in the previous paragraphs on graphing the other types of inequalities, it is clear that if a second-order equation is expressed in the standard form as the one shown, the following rules are true for the four corresponding inequalities. The condition is that a greater than 0, 1. The solution set of the inequality y greater than a, x squared plus b, x, plus c, includes the zone above the graph, parabola, but not the graph line. 2. The solution set of the inequality y less than a, x squared plus b, x, plus c, includes the zone under the graph, parabola, but not the graph line. 3. The solution set of the inequality y greater than or equal to a, x, squared plus b, x plus c, includes the zone before the graph, parabola, as well as the graph line. 4. The solution set of the inequality y less than or equal to a, x, squared plus b, x plus c, includes the zone under the graph, parabola, as well as the graph line. Let's clarify this point through an example. Example. Solve graphically the following inequalities. A. 2x squared minus y plus 3 less than 5x. B. 2y minus x minus 4 less than or equal to 5x squared. Solution. A. First, we must turn the given inequality in the form y, a, x, squared plus b, x plus c where represents one of the four inequality symbols. We have the following shown on screen. Looking at the inequality from right to left, we have the following shown on screen. Since the graph is not linear anymore, we need more than 2 points to plot it. The more points we consider, the more accurate the graph is. We will not dwell too much on this point, as in the upcoming chapters, we will explain extensively how to find some special points contained on a parabola that help us plot the graph easier. However, we anticipate that a parabola graph is plotted by joining at least 4 special points, 1, the two x-intercepts a and b, that have the vertical, y, coordinate 0, they are obtained by solving the corresponding quadratic graph a, x squared plus b, x plus c, equals 0, as the x-intercepts represent the x-coordinate of the roots. Thus, we have a, x to the power of 1, 0, and b, x squared, 0, 2. The y-intercept c, 0, y, that is obtained by taking x equals 0 in the corresponding quadratic equation, and 3. The vertex v of the parabola represents the minimum or maximum point of the parabola. It has the coordinates v minus b over 2a minus alpha over 4a, where is the discriminant of the corresponding quadratic equation. Finding all the previous points, and some others if possible, we obtain the following graph for the quadratic inequality solved before, a graph that includes only the region before the parabola without the parabola line. We have the following shown on screen. B. Here again, we must turn the given inequality in the form y, a, x squared plus b, x plus c. We have the following shown on screen. Or we have the following shown on screen. Applying the procedure described in A, for the graph plotting, we obtain the following graph, which includes the region shown, the parabola as well as the parabola itself, because the sign of the inequality is less than or equal to. We have the following shown on screen. That is all for lesson 10.3.4, and the end of tutorial 10.3. To continue this chapter, please watch 10.4, Introduction to Systems of Inequalities. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.